This video is part 5 in a series of narrated longer form videos accompanying my A-level chemistry speedrun series. So in these I'm just going through the exact same exam questions but a little bit slower and narrating what I'm doing so that if you want the full explanation rather than just the 30-second speedrun, then you can get it. This kinetics question is really a 3-part question. So part 1.1 would be drawing and labelling your Maxwell-Boltzmann distribution, although the exam board would probably be nicer than me and actually give you some axes. And then part 2 would be drawing your second distribution to talk about how temperature impacts that. And then your third part would be explaining the impact that this has on rate. So first off, we're going to need some axes. And as always, we're going to have energy on the x-axis. So you've got particles that have no energy at all. In other words, they kind of must be at absolute zero or it wouldn't happen, far on the left-hand side. And then as we go over to the right, the particles gradually have more energy. And then on your y-axis, you have frequency or number of molecules or something that just means the same thing. So your overall basic shape is always the same shape, although the dimensions of course may vary. So we have this sort of very left skewed normal distribution, except that then on the right hand side it asymptotes, so it goes off into the distance and never actually touches the x-axis again. So when you draw this, it's important that we're starting from the origin, so we're not implying that there are any particles in the sample that actually have no energy at all, because that wouldn't happen unless it was at absolute zero. We have this left hand skew, and then also we have on the right hand side this asymptote, so your line is getting closer and closer to your x-axis. The official marking guideline is something like no more than 10% of your particles can be under that bit of the curve, so really you just kind of want to get as close as you can without getting so close that your examiner might think you've accidentally touched it. So just keep a little distance away, but only a very, very little one. So that's my T1 curve. And now we're going to have the curve at the higher temperature. So remember, as you heat this sample, all of the particles are going to get slightly more energy than they had before. So we've still got the same basic shape, but now we're not quite as far skewed to the left as we were before. So this is T2. So the first thing that's going to be important about these curves is that the area under the curve represents the number of molecules, and that hasn't changed. We've just heated them up. So we're going to have approximately the same area under the curve. Your examiner is not going to get out their squared paper and check, but we don't want something that's only sort of a quarter of the size. Secondly, we're going to have a higher peak for T1. So if you think about it, T1 is our colder temperature, and therefore on average, the particles have less energy. And so if you think about the sort of range of energies that they could have, it's going to be narrower. So say, just for the sake of argument, if we had from 0 to 10 joules within our particles at T1, and then at T2 it's hotter, so we go from 0 to 20 joules, right? That's a bigger range. So because we've got a smaller range of energies for our lower temperature, our T1, that means that each one of those energies is going to have more particles associated with it, essentially. So that's why we've got this higher peak. Then our third thing is that the T1 peak is of course going to be further to the left, because this is the cooler temperature, so the particles have less energy on average. And then also it's important on the right hand side that we don't cross back over T2 to T1. So basically you're always expecting for high energies for there to be more particles with that energy for T2. The only reason that T2 is underneath T1 on the left hand side of your graph, sorry this is getting complicated to explain, is because if you've got more particles with high energy, those particles must have come from somewhere, right? They're low energy particles that have been heated up and become high energy particles. So that's everything that we need with our two distributions. And now we need to explain, why does this have an impact on rate? And the thing you need to be super careful of here is that for A-level questions, it's very likely that you're going to have some kind of qualitative description or even quantitative description that is important. So at GCSE, we regularly asked you, why is it that increasing the temperature would increase the rate of reaction? And you know how to answer that question. And so then at A-level, you see a question like this one, which talks about a small increase in temperature and a large increase in rate of reaction. Or even sometimes they give it to you as, why is it that, say, doubling the temperature will have this particular impact on the rate of reaction? And they actually put numbers in there. And people answer it as if it's the GCSE question that just says, why does increasing temperature increase rate of reaction? So you just need to be careful of that, because very often we'll see people write answers which are factually correct but not credit worthy because they don't go far enough. So if I look at my distributions here, I can add a line to show me the activation energy, and I can put it wherever I like. But the important thing is that as we've increased the temperature, the number of particles that are represented by the curve to the right hand side of that line has dramatically increased. So in order to answer the question, I would say at higher temperatures, many more molecules have the activation energy for the reaction, and it's that many that's going to get me the mark. Thanks for watching, and I hope that you are finding these videos useful. If you are, then don't forget to like, subscribe, comment, tell me which topics you'd like me to cover next, and also share the channel with your friends. I'll be back soon with some more A-level chemistry content.